Okay, carrying on from where we left off with the discrimination of fusing. Remember, we have 3 fuses in series here. This represents the 100 amp fuse at the cutout. This represents a 32 amp fuse, or it could be a circuit breaker, in the consumer unit of a customer's property. And this 13 amp fuse is inside the plug top operating a domestic appliance. And discrimination means that these fuses must be substantially different in order to make sure that the one nearest the fault blows first. So if, for example, in a washing machine a live wire came off and touched the metalwork of the machine, you get a lot of current flowing down to earth, and we want this 13 amp fuse to blow before the 32 amp fuse or breaker in the circuit board, and definitely before the 100 amp fuse here. Occasionally customers do try and buck the system by possibly putting a nail or a safety pin or something across the fuse link if they don't have a fuse for that, and similarly they could do the same in the circuit board. If that's done, then an awful lot of current has got to flow through the whole system in order to make this cutout fuse blow, and that could actually cause a fire in the property. So discrimination is when the fuse nearest the fault blows first. On high voltage fuses, and these are actually physically very large. They can be probably, this is a bit larger than this, actually physically larger than this diagram. Unfortunately I don't have any big fuses with me at the moment because of the lockdown. I can't get access to them. But I will put a video on showing how a fuse is actually made, which is quite good, and it shows you this expulsion pin. So in a fuse you have a cartridge tube usually made of porcelain or ceramic on the outside, and inside there'll be a fuse element, which is a specific piece of conductor that's designed to melt when a certain current flows through it. And when the fuse blows, a lot of energy is produced, and you can make that energy operate a small explosive charge which is stuffed under the end of one cap, and that can push out a pin, a physical expulsion pin, which is shown in the video that I'll put up, and that pin actually can then operate. It also acts as an indicator that the fuse is blown, but it can actually be used to operate a mechanism which will operate a circuit breaker to disconnect all 3 phases. So this can operate a switch. So it acts as a trip mechanism to operate a much physically larger switch. Okay, so this is called a striker pin. Or an expulsion fuse. So this term expulsion fuse, striker pin, often crops up in some of the questions, so be aware of that. Okie dokie. So that's pretty well it really for the fuses side of it. Just to recap on the symbols, you need to remember that symbol is an isolator, that symbol is a circuit breaker, and that symbol is a switch. And of course we know that that symbol is a fuse. Circuit breaker, switch, isolator. Sometimes it's also called a disconnector. Sorry, I'm trying to fit my hand in here. Disconnector. There's two words. Sometimes it's called an isolator or a disconnector, and they're usually all used in combination. This protects the rest of the circuit from becoming live in the event of servicing. The switch is a way of actually controlling the circuit, making it go on or off, and the circuit breaker and the fuse are what we call protective devices. These are operated when the current going through the circuit gets too high. Okay, so if you have a look at the video on how a fuse is made, I'll put that up shortly. Thanks very much. Bye now.